Today we'll be learning how to apply the product, quotient, and chain rule to tables and graphs. These rules are vital in calculus in order to correctly compute derivatives of two or more differentiable functions. The first rule that we have here is the product rule, which is used to find the derivative of the products of two or more differentiable functions. In this rule, you take the first function and multiply it by the derivative of the second function and add that to the second function multiplied by the derivative of the first function. Next, we have the quotient rule, which is used to find the derivative of the quotient of two or more differentiable functions. In this rule, you multiply the function in the denominator by the derivative of the numerator and subtract the function in the numerator multiplied by the derivative of the denominator and divide all that by the function in the denominator squared, or you could do low d high minus high d low over low low. Next, we have the chain rule, which is used to find the derivative of the composition of two or more differentiable functions. You take the derivative of the outside while keeping the inside unchanged, and you multiply that by the derivative of the inside function. Each of these rules can be used singularly or combined in order to correctly find the derivative of the functions and solve for specific values of x through tables and graphs. In tables, the values are given, and in graphs, the lines are plotted. So first, we're going to look at table problems, and this first example utilizes the product rule. So the function given is p of x equals 4f of x times g of x. So first we're going to write out the first function and find the derivative of it, which will be 4f prime of x, and then write out the second function, which is g of x, and find the derivative of it, which is g prime of x, and then utilize the product rule, which will be the first function times the derivative of the second function plus the second function times the derivative of the first function, as shown. And the problem asks to find p prime of 5, so we're going to plug in 5 for all the x values as shown, so g prime of 5 plus 4f prime of 5 times g of 5. And then we are going to look at the table of values given and look where it says x equals 5 and use those values as shown below and plug them in for each of values, and then that's gonna equal 8 plus 4, which will be 12. And that's it for the first example. As you can see here, all you got to do is apply the product rule and then correlate the values in the table to the problem. The second example here utilizes the quotient rule. So k of x equals f of x over g of x, and we're going to do the same thing. Write down the first function, find the derivative, which is f prime of x, and then the second function is g of x, and find the derivative, which is g prime of x, and then apply the quotient rule, which is low d high minus high d low over low low. In other words, the bottom function times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And then it's asking for k prime of 3, so we're just going to plug in 3 for each of those x values as shown, so minus f of 3 times g prime of 3 over g of 3 squared. And then we are gonna go back up and look at the table of values where it says x equals 3 and plug in for all the values in the derivative as shown. So that's going to be negative 1 times 10 minus 4 times 1, all divided by negative 1 squared. And that is going to get us 10 minus 6 over 1, which is just going to be 4. So in this problem, in the second example, it utilized the quotient rule as shown. Now this third example of a table problem utilizes both the product rule and the chain rule as shown. So the function is h of x is equal to f of x times g of f of x. And so we're going to do the same thing. We're going to write out the first function, which is f of x, and find the derivative, which is f prime of x. And then for the second part, we're going to be utilizing the chain rule in order to find the derivative. So we are going to write out the first function, which is g of f of x, and then the inner function is going to be f of x, and then find the derivative of both, which is going to give us g prime f of x times f prime of x, and that is going to be the derivative of our second function. And so now we're going to apply the product rule. So that is the first function, which is f of x, multiplied by the derivative of the second function, which is g prime of f of x times f prime of x, and then add that to the derivative of the first function, f prime of x, times the second function, g of f of x. And then it's asking for h prime of 1, so we're just going to plug in 1 for all of the x values as shown. So f of 1 times f prime of 1 plus f prime of 1 times g of f of 1. And then we're going to look at the table of values above and plug in all the numbers. So that's going to be 2 times g prime of 2 because it's a composition of a function. So that means that you still have to find g prime of 2 and g of 2, and then look back at the table for those values, which is 2 times negative 8 times 4 plus 4 times negative 2, and that is going to equal negative 64 minus 8, which will be negative 72. So in this problem, you can see how both product and chain rule were utilized. So in this example, we are going to be looking at a graph to find our values. And the function given is m of x equals 2h of x plus x divided by j of x minus 1. So we are going to be utilizing the quotient rule. And we are going to write out the first function, which is 2h of x plus x, and find the derivative, which will be 2h prime of x plus 1, and then do the same thing with the second function, j of x minus 1, and find the derivative, which is just j prime of x. And then we're going to apply the quotient rule, which is the bottom times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared, as you can see here, minus 2h of x plus x times j prime of x, and this is all going to be divided by j of x minus 1 squared. And the function asks for m prime of 1, so we are just going to be plugging in 1 for each of the x values, so j of 1 minus 1 times 2h prime of 1 plus 1 minus 2h of 1 plus 1 times j prime of 1, and that divided by j of 1 minus 1 squared. And now, in order to find the values, we're just going to be looking at the graph. So to find the values on the graph of just j of 1 and h of 1, we're going to see what they equal at x equals 1 at the lines plotted. And to find the derivative of j of x and h of x, we're just going to calculate the slope at x equals 1 in order to get those values. So over here we have 2 minus 1 times 2 times negative 3 plus 1 minus 2 times 3 plus 1 times 2 all over 2 minus 1 squared, which is going to give us 1 times negative 5 minus 2 times 7 over 1 squared, which is just negative 5 minus 14 over 1, which equals negative 19. In this problem, we used the quotient rule and found the values through a graph. So this is another example using a graph. And as you can see here, we are going to be applying the chain rule multiple times, and the function given is w of x equals p of q of 3x minus 1. So the outermost function is p of q of 3x minus 1. Then the inside function is q of 3x minus 1, and the innermost function is 3x minus 1. So in order to apply the chain rule and find the derivative of this, we have to take the derivative of each of those functions. So the derivative of the first function is p prime of q of 3x minus 1. The derivative of the second function is q prime of 3x minus 1, and the derivative of the third function is just 3. And it's asking us to find w prime of 1, so we're just going to plug in 1 for all of the x values here, and that is going to give us p prime of q of 2 times q prime of 2 times 3. And we're going to be looking at the graph here to find where q equals 2 and find where q prime equals 2 as well by looking at the slope of the graph. And that is going to get us p prime of 1 times negative 1 times 3. And now we're going to look at the graph to see what the slope of p is at a value of 1. So once we calculate that out, we are going to get a value of negative 2 times negative 1 times 3, which is going to give us negative 2 times 3, which equals negative 6. So in this problem, we applied the repeated use of the chain rule in order to solve. In this last example here, we will be utilizing both a table and a graph to solve the function, which is m of x equals f of g of x divided by 2h of x. In this problem, we will be using both the chain rule and the quotient rule in order to solve. So first, we're going to write out the first function, which is f of g of x, and here we're going to apply the chain rule in order to find the derivative. So the outermost function is f of g of x, and the inner function is g of x, and we're going to find the derivative of both, which is going to give us f prime g of x times g prime of x. The second function is 2h of x, and the derivative of that is just going to be 2h prime of x. And now we're going to apply the quotient rule, which is just the bottom function, which is 2h of x, times the derivative of the top function, which is f prime of g of x times g prime of x, minus the top function, which is f of g of x times the derivative of the bottom function, which is 2h prime of x, all divided by the bottom function 2h of x squared. And the problem is asking to find m prime of 8, so now we're just going to plug in 8 for all of the x values. And over here we're just writing out g prime of 8 minus f of g of 8 times 2h prime of 8 all over 2h of 8 squared. And now we are going to look at both the table and the graph for values. So over here, we are going to be using the table for h and h prime values, and for f and g values and their derivatives, we're going to be looking at the graph. Remember, to find the derivatives of values on the graph, we have to calculate the slope at that point. So over here, we have 2 times 2 times f prime of 2 times negative 1/2 minus f of 2 times 2 times 1 all over 2 times 2 squared, which is going to give us 4 times 1 times negative 1/2 minus 7 times 2 over 16. And that is going to give us negative 2 minus 14 over 16, which will give us negative 1. So in this problem, we utilized both the table and the graph in order to solve m prime of 8. That's it for all the example problems. All the problems and tables were created by me, but they were inspired by calcworkshop.com and the Black River Math Circuit by Vicky Carter. The first graph was from there as well, and the second graph was from activecalculus.org, and the third was from mathfortress.com. Hope you learned a lot through this video. Bye!